if you're already a Java programmer or any object-oriented programmer, you should be well familiar with the use of packages. So a package is a namespace within which you put your related classes. Let's say. So anything that's related, anything with an inheritance hierarchy, or any bunch of classes that are doing the same thing on the same project, then you put them within the same namespace. So you use that to unambiguously identify related classes. So for example, I could tell you to create a class for a car, for example, or a project for a car. The way that I distinguish between all your different projects is that I look at your different namespaces, obviously. So it's kind of a folder on a computer, if you like, with a particular IP address, if you like. So I can find your specific project by looking through the namespace, your particular namespace. Packages provide scope for accessibility of classes and their members. So as you know, there are different accessibility modifiers for classes, for interfaces, for member variables, also for packages as well. So there's something called package private, for example, where classes can use each other's variables and methods. Obviously, classes in a package can be imported. Most Java programs that are useful import one or more libraries. So something you should already be familiar with. Right at the top of the Java class, you use the import keyword, and then you import any of Java's libraries. You can also import your own packages into a particular program to do things with. So use packages to provide an informal hierarchy structure to your code base. Always use packages. And something that I see sometimes, people trying to declare their own classes to be members of Java or JavaX packages. Obviously they don't understand how packages work. So obviously your classes can't be part of the Java main library. So you need to create your own packages. And the convention is that when you create a package is that you start it with the organization's internal domain. So for example, a lot of the examples that you'll see or you've seen already for this module, at the beginning they start with ncl.ac.uk reversed. ncl.ac.uk reverse teach, and then whatever example comes afterwards. Okay, so that's the convention. So top level class access is usually either package private, which is the default access. So if you don't add an accessibility modifier to something, then it's by default package private. Private, you can only access stuff from within the class itself only. Package private means that you can access data and methods from within the class, but also from within the package itself that you own. So that's what package private means. So it's either package private, which is default access, or public. So conventionally, you decide, is this a class only for me, in which case it's package private, or is it a class that I intend for the outside world to use, in which case you declare that it's public. So whereas class member access, so the members of your class, so you've got, conventionally you can use any of the accessibility modifiers. You can decide that you want them to be private, which means accessible only inside the class where the member is declared. Package private, again, you can make use of that for your members, accessible only from the classes in the package where the member is declared, so that's the default access. Protected means accessible from classes in the package where the member is declared, and from any subclass of the class containing the member. So protected gives a little bit more access than package private. It says I can access the members from within the class itself, from the package, and from any classes that extend my stuff. Okay, so that's what protected means. Protected is a very, it's sort of a confusing kind of term, and the general advice is not to use it. Okay, so be a bit more explicit about your code. So either it's public or it's private, or possibly also package private is fine. So here's a nice table just to show you the differences between them. So obviously, if it's public, then it can be accessed from the class, the package, a subclass, or the world. So public means give access to anybody. Protected means access from within the class, the package, any subclass, but not from the world, rest of the world. And no modifier is the default package private, accessible only from within the class and the package. So it's quite standard to do this. Private means just from within the class itself. So general advice is to minimize accessibility as much as possible, and you release accessibility just when it's needed. Okay, so you don't just make everything public. So make everything private, and then have a look at your code and decide actually this bit needs to be accessed by the public. In which case, make it public. So start with everything private, and then see what can. So start from a secure point of view, and then gradually see what needs to be public only. So make each class and each member of a class as inaccessible as possible. Okay, so you want to think from a secure point of view first of all. For classes, favor package private. So obviously you want your own classes to be accessible by your own code. So you want another class within your package, possibly if they belong to the same hierarchy, the same computer program, to be able to access each other, those classes. So package private is the preferred accessibility modifier for classes, assuming you're using packages, which you should be. For members, favor private, so make everything private before package private. It says here before protected, but my advice is just don't use protected at all before public. And the general advice is just make your stuff private. Okay, so any data, you don't want anybody to be able to access your data. So you want to allow access to your data only through methods. Okay. So public and protected are part of the exported API and incur obligations for future support. So keep that in mind. Any of your methods or any of your anything that you make public, essentially protected basically also means public, because if somebody extends it, they can use it anyway. So if it's public or protected, then you need to provide support. You need to tell the outside world whenever you've updated the code, so that they know about it and they can modify their own code as well. So member fields, non-static member fields should always be private and preferably final as well. So preferably, again, thinking from a secure point of view, unless a variable needs to change its value, then ideally make it final so that its value can't be changed. So just as I said, avoid protected, it leaks implementation detail. Yeah, so one of the techniques that we use in order to increase security of our code is something called defensive programming. And it's a very important technique, and the general idea behind it is when you pass an object into another object, this object now can be manipulated from two places. So potentially, if you've got a complex, large piece of code that's being used by not just by yourself, multiple people, or even just by yourself, the state of the object could change in ways which you can't predict, possibly. So what you want to do is you want to make sure that objects are isolated from each other. Whenever you pass an object into another object, you want to separate them into two objects. Okay, so that's the ideal scenario that you want to do. You don't want the calling object to be able to change values for an object that's intended for another object. So that's the general idea behind defensive programming. Okay. So the general idea is whenever values are passed into your class, the first thing you need to do is check them for validity. Do they match the values that you expect them to match? So check them for validity. So that's item number 38. For public methods, never trust the inputs. Fail quickly and cleanly. Document exceptions that will be thrown, including unchecked exceptions. So for unexported, non-public methods, assert the validity of parameters, and inputs should always be under your control. Okay. So here's an example of how you would do some defensive programming. I've got a method here, and it's getting somebody's details. So we're passing some kind of a string to it. Here it's a key. So a very typical thing that you should always do whenever a string or any object is being passed into a method is to check for null. So here we're saying if the key is equal to null, then throw an illegal argument exception. So here we've given a useful message saying null key and get details. So here we're doing some kind of defensive programming. We're checking the parameter being passed, making sure that it's valid before we actually go ahead and return the value. So that's an example of checking the parameters. So that's something you should always be doing. So here's an example of something else that you can do if you want. So I've got contact details method again, but in this case we're passing a number of strings. So I've got a name, a phone, an address, and in this case I've decided that it's okay if one of these values is null. I can still get something useful from the class. So I've put some guards at the start saying if the name is null, then set it to a 0 string. So name is equal to a 0 string here. If phone is equal to null, then set that to a 0 string as well, and if address is equal to null, and set it to a 0 string, and then decide what to do with them later on within the logic of your code. So then I'm saying this name is equal to name.trim. So we want to remove the spaces. So let's say somebody's provide you with a long name and it's got some spaces in it, so we want to remove it. In this case, we just want to have the actual string. So we're removing we're doing trim for the name, the phone, and the address first of all, and then we're checking the length of the string that's being passed in. So we're saying if the name's equal to the length of the name's equal to 0 and the length of the phone's equal to 0, then only then throw an illegal state exception. So here we're looking at the entire state of the object. So that's why we're throwing an illegal state exception, because we're looking at the whole object. We're looking at a number of arguments or a number of parameters, and if we're not happy that we've got enough information to record some data, we're throwing. So notice we're doing something with the data. We're not saying that just one of them is null, therefore illegal argument exception and it's invalid. We're allowing some kind of flexibility. So you can do that within your programs as long as you know what you're doing and as long as you have some kind of control over the data that's entering into your class. Okay, so here's an important point to bear in mind. So always use exceptions in the correct way. So never try anything like the following. So have a look at this code and see what this person's trying to do here. So in this case, you've got somebody using exceptions in a situation where exceptions are not intended to be used. So I've got an integer value I set to 0 to start with. Then I'm saying while true. While true basically means that do this forever. Okay. While true, do something to some array and increase the index gradually while you're doing this something. And then whenever the array gets to the end, we'll end up with an array index out of bounds exception. So they're using exceptions to end the loop, which is not the correct way to write a computer program. So don't do something like this. Use exceptions in the correct way, how they're intended to be used. So exceptions should never be used for ordinary control flow. A well-designed API does not force clients to use exceptions for ordinary control flow. So a side note, favor the use of standard exceptions. So the Java API provides a number of standard exceptions. So make use of them. Why? Because programmers are more familiar with them and they can understand them better. They know what an illegal argument exception is. They know what an illegal state exception is. So there's a number of exceptions which are commonly used within the Java community. It makes your code more standable. It makes it easier to debug code when errors happen, because they look at the exception, they recognize it, and they know how to correct the code. If you can obviously override or extend the exceptions classes that are already provided and provide your own exception classes, but only do that when absolutely necessary. If the already provided exceptions are sufficient, then just use them. Yeah, so this refers back to what I was talking to before. So make defensive copies when needed. So this refers back to the point that when you're doing defensive programming, you should also do defensive copying. So whenever an object is being passed into another object, create another object. Don't just allow to have multiple references to the same object from outside of your class. So that's what's basically happening when you pass an object. So remember, Java is pass by value, which means that when you pass an object from outside your class into your class, you'll end up with more than one reference to the same object, and now the object can be manipulated from multiple places. So unless that's your intention. Unless that's your intention, if you want to allow the object to be manipulated from multiple places, that's fine. But if it's not your intention, then don't allow it in the first place. Make defensive copies. So the idea is to make defensive copies of each mutable parameter. So if it's a mutable parameter, meaning that its value can change to a constructor or to any mutator method. Obviously, if it's immutable, then that's no problem. If you're passing around objects whose values are constant and can never change, then you don't need to do this. But if it's mutable, if it's changeable, then you do need to do this. You need to perform defensive copying before checking the validity. So that's the first step. Okay, so we'll look at an example of how to do that in a second. And when doing copying, when doing defensive copying, do not use clone. So there's only one type of object that I'm aware of that you can use clone for safely. So within the Java API, there's a date object, there's a date class, and they've already implemented clone, and you can make use of the date object, the clone method within the date object in order to make copies of dates. So do not use clone to make a defensive copy of a parameter whose type can be subclassed by untrusted parties. Also within the get methods, you need to also do defensive copying within the get method. So you need to do this twice. Whenever you pass the object into your object, and also when you return the object from your class to be called somewhere else. So a get method might return the object. Again, then you need to do defensive copying as well. If all your objects are immutable, or your classes are immutable, then you don't have to do defensive programming later on, because basically there's only one instance of each object anyway, so it can't be modified anyway. Somebody's just using the object to read some data. No modification of the object is going to happen. Obviously, if the object is something that needs to be modified, then we can't do this. So for example, string is immutable. So once you create a string, that object string is never going to, its fix is never going to change. If you actually try to give a different value to the reference of that string, then what's happening is actually you're creating a completely new object, and the old object now doesn't have a reference to it, and it's just getting deleted. So strings are immutable. Date is not immutable, so dates can be changed, but should be, according to Joshua Block. So when he writes in his book about date, he says that he wishes that initially when they designed Java, they made date immutable, because obviously a date is something that once set, somebody's birthday, for example, you don't want that to be changed. So to make a class immutable, so these things that you need to do. So don't provide mutator methods that modify object state. So you don't want to have setter methods. So you know the methods that you have within a class that say set a particular field to a particular value. So you don't have any of those methods. So you forbid method overriding. So you make them final basically. You also make all fields private and final. And you also need to use defensive copying. So within your immutable class, any objects that are passed through the constructor or through your methods, you need to use defensive copying to make sure that basically you've got a copy just for yourself within that class that nobody can manipulate. So that way any objects you create from your class then are immutable. Advantages of doing that: so immutables are simple, safe, and make good building blocks. You know, you've got a safe object there that nobody can manipulate. It's only an object that's immutable, it's always in one state. They're also thread safe, because even if you've got multiple threads converging on a single object, all they're doing is reading from the object. They're not changing the object state at all, so there's never going to be any inconsistency. And obviously they can be cached if it's the same object, not going to be changed. You can cache it somewhere to be accessed by anybody. There's also no need to defensively copy or clone any immutable, because it's safe in itself as well, so there's no need to copy it. Yeah, so it's easier to maintain mutable classes that are building a foundation of immutable objects. So Joshua Block's item number 15 is minimize mutability as much as possible. Make your objects immutable where you can. So here's an example. So we've got a class here, and it's called immutable person. So our instances of the following class actually immutable. So it takes two fields. So you've got a name, you've got a date of birth, and what it does, it checks the parameters for validity initially within the constructor. If it's named, if name's a null, do something, throw an exception. If date of birth is null, do something. And we've got a couple of getter methods. Notice we don't have any setter methods here, only getter methods. So have a look through that. So and decide whether or not you think if instances of this will be immutable or not. So what sort of questions should you be asking initially? So you need to know if name is immutable. So if you look at the name class here, you notice that it's got a set first name method and it's got a set last name method. Therefore, the name class is not immutable. It is mutable. So it's not a safe class. People can make changes to it after they've passed an object to your own objects. So we need to defensively copy name. So this is how you would do it. So this is a correct implementation of an immutable person. Obviously, these two need to be private, and then name and data passed into your constructor, and you basically need to make a new copy of name. So you just say this name is equal to, in this particular example, you say is equal to new name, name.get first name, name.get second, get last name. So you've created a new name object. So you've created a copy to manipulate within your own class that can't be affected from the outside. Same thing for date. The way you create a copy of a date is you say new date of birth.get time. It gets the date in milliseconds and then converts it to a date that you can manipulate. And you shouldn't have any setter methods. You just have getter methods. But remember, within your getter methods, you also need to do defensive copying. So one thing that people do is they do defensive copying within the constructor, but they don't do it within the getters. So you don't want to return your own copy. If you return your own copy, then you've given people access to it, and people can manipulate it. So you want to create a different copy. So you create a new copy and you return that. And you also create a new copy of date, and this is just showing you that date is the only one that you can use clone with. So you don't have to use clone here. You can do it the same way you did here. This is just showing you two different examples in which you can make a copy of date. But you don't use clone for anything else. Just use it for date if you want. So immutability is an important behavior when considering sets. So the way that a set works is at construction, it'll make sure that there are no duplicate elements within the set. So at construction, once you put elements within the constructor, or even when you use the add method of the set, it'll make sure that elements they're not copies of each other, or they're not the same. But after that's done, remember what's inside a set is a bunch of objects. So if an object has a reference from outside the set, there's nothing stopping whoever owns that reference of manipulating objects within the set. If a set's elements are not immutable, then somebody can break the set semantics, and they can mix elements within a set to be the same if you want. So therefore, the advice is make elements of a set immutable, so nobody can manipulate them. So the behavior of a set is undefined. If a change to the value of a set element affects the element's equal comparison, the set itself can't guarantee the no duplicates invariant if you have elements that can be manipulated. Also, so one of the problems, for example, is that a sorted set can't guarantee the correct order. So avoid holding mutable objects in a set, including the map key set as well. So any implementation of sets, make sure that, so try as hard as possible. So once you put elements in a set, make them immutable so they can't be modified. Unless you need them to be modified for some reason, then you're just going to run the risk of that happening. So use immutable objects for set elements and for map keys, or provide an immutable wrapper for mutable elements. So one thing that you can do is, so remember we've got these collections utilities classes within the utilities package. So there are methods in there for you where you put a set in it and it'll automatically create a wrapper that'll prevent any of the objects inside it to be manipulated. So you can use the utilities to do that for you. Or ensure, this is almost impossible to do, ensure that mutable objects do not change while they belong to a set. So it's a difficult thing to do because you've got to keep track yourself of all the objects within the set, which is not easy to do.